What do we do when we solve a question and there's a horizontal compression in the question? Okay? I give these questions a special name. Sometimes when you name something as a certain type of question, it triggers your memory, oh, this is what I need to do, and it makes it a little bit easier to remember and to do it later on. So I give this one a name. I call this, and if you look this up on Google, I might be the only person in the world that calls it this, so it's not like, it's just to help you guys, okay? So I call this a multi-revolution question. And giving it that name is just a way for you to remember. But if you go to university in a couple years and say to your friend, hey, this is a multi-revolution question, and they'd be like, give you that look, like they have no idea what you're talking about, it's probably because they have no idea what you're talking about. But the way that a multi-revolution question works is as follows, and why I call it this, okay? If you're solving for 3x equals 0 over the domain from 0 to 2 pi, we're going to write sort of our steps off to the side here, and we'll do things as we go. Okay? And part of the steps, I'm going to put in quotation, rewrite the domain, and I put the 3x in quotations because we have a 3x in our question. If it was a 2x, you would rewrite the domain for 2x. If it was a 7x, you would rewrite the domain for 7x. And the way that it works is as follows. If x is between 0 and 2 pi, whoa, notice that they didn't include the equal sign here? They're trying to trick us, I tell you. Careful. If x is between 0 and 2 pi, what is 3x between 0 and 6 pi? This is like if I got you to pick a number between 1 and 10, and then I told you to multiply it by 3. Does it make sense that the number you picked is now somewhere between 3 and 30? If you started between 1 and 10 and you multiplied by 3, it would now be between 3 and 30. So if I started between 0 and 2 pi and I multiply x by 3, it's now going to be between 0 and 6 pi. Next, you're going to solve for 3x over its domain. In other words, like, if this was just a theta, could you just solve for theta? You would write theta equals. So if I was just solving for 3x, I would write 3x equals. Well, when is this on your pie plate? Is your y coordinate 0? Yes, that's axis family. When is sine equal to 0? Looking for your y coordinate. Is it at 0? Okay, it's at 0. Anywhere else? Is it also at pi? Is it also at 2 pi? All the way around it would be, again, do I include 2 pi?
Yes.
Yes, because 3x is between 0 and 6 pi. So that's what this means. When you solve for 3x over its domain, we have to go to 6 pi. We have to go 3 times around the circle. So with the 3 inside, I call it a multi-revolution question because initially you solve 3 times around the circle, more than once. So we will include 2 pi. Do we keep going? Yes, we would include 3 pi, and 4 pi, and 5 pi, but you wouldn't include 6 pi because the textbook is being mean to us, and tricky by not including that little line under the less than sign. So step one, we rewrite the domain to tell us we're going 3 times around. That's what makes it a multi-revolution. Next, we solve for 3x over its domain. If I went 3 times around, sine is equal to 0 at a whole bunch of places going 3 times around. At 0, at pi, then at 2 pi, then at 3 pi, then at 4 pi, then at 5 pi, and 6 pi, but we don't include 6 pi because it's not part of its domain. And then the question didn't ask us to solve for 3x, we wanted to solve for x, but if 3x equals each of these, can you see that you can find x by taking each of them and dividing by 3? And when you divide each of them by 3, all of our final answers, all 6 of them, are between 0 and 2 pi, which was originally what they wanted. They wanted x between 0 and 2 pi. We first had to solve for 3x going 3 times around, and then we solved for x after that. Okay? State the general solution, so part B. Again, the general solution is relatively easy. Once you've solved between 0 and 2 pi, we got those 6 answers. Write all 6 of them out. And add 2k pi to each of them. And to find k to be part of the integers. And this is the multi-revolution question. Whew. So again, some people like to actually do this. It's perfectly fine if you want to do this. Just say, this is confusing for me with a 3x there, so I just change it to a theta. Then you would rewrite your domain for theta. Well, so you would say that theta is between 0 and 6 pi. Then you would solve for theta and get all of those answers. But then you'd have to substitute back and rewrite it with, then you would substitute back and rewrite the 3x, and then have to divide by 3 anyways. Okay, I think you're capable of avoiding this and just saying, okay, I have a 3x inside, I can just solve for 3x. These are the answers I get. And then divide by 3 in the end to get x. But what we're basically doing is we're just pretending that 3x is one thing. That's our theta. And I'm solving for that one thing. And because I know that x is between 0 and 2 pi, tripling that would be between 0 and 6 pi. So again, a lot of review from chapter 6, because this question just solves it more than one time around, so it's practicing coterminal angles. But on your test, you won't get any multi-revolution, not until your chapter 7 test. But for your chapter 6 test, it'll just be regular sin x, cos x, tan x questions. Questions for practice on this one? us number 10.